Hello and welcome. In this video, I'll be talking about dealing with open-ended problems. So let's look at an open-ended problem. Create a program that converts a DNA sequence into its reverse complement. So we know about the base pairing scheme of DNA, right? For any given sequence, we have a potential reverse complementary sequence that could pair with it. And this, of course, is something that you can easily do in a browser. If you Google, compute the reverse complement, you'll get a link to this browser-based tool that allows you to input a sequence and generate a reverse complement. So how does this work? And how would we go about implementing a tool such as this one? So solving problems when you don't know where to start. This is going to happen most of the time because most problems are open-ended. Most real problems, are going to be said in terms of real things, end products. They're going to be kind of results focused and less focused on the details on how you get there in a real practical scenario. So we need to be able to formulate solutions as programmers and implement them. And this is a list of strategies. It's probably not close to complete, but this should get us started. So the first thing I recommend is identify the goal. Usually this is the clearest part of any problem. And if it's not clear, then chances are it's a good sign that the problem needs to be better defined in the first place. So start from the end and try to figure out the goal. Dissect the problem, okay? It can be overwhelming sometimes to be faced with a problem. Try to break it down into smaller parts. Play around. So we have live programming environments, and a lot of times we'll get ideas if we just start to try things, and it doesn't necessarily need to be too structured or serious at first, but starting to create the data structures maybe that we need, and starting to identify the potential confusing points just by what don't we know how to implement exactly. Playing around is really useful. Draw a diagram. So in previous videos we've shown you a few of these flow charts, and we'll go through some more of these, but this can be a really useful tool to visualize how a program ought to work. And then finally, research. So in this day and age, we have a lot of available resources on the internet that we can use to help us figure out how to start even the most open-ended of problems. So let's go through these in a bit more detail. Identifying the goal, right? Sometimes the easiest place to start is the end. You want to think about the program structure, and it can be good to work backwards from the end and think about, what is the output? Is it an array that we need? Is it an integer? A lot of times the step immediately prior to that will start to become clear. What do we need before we get to the end, and just work backwards. Let's try that with our open-ended problem here. Create a program that converts a DNA sequence into its reverse complement. So we know we need a sequence as our output. So it could be a string, for instance. It should be composed of characters, string characters, but specifically the DNA bases, A, T, G, and C. Those bases should be complementary to some kind of input sequence, I guess, that we're going to give the program. And we know that the order of corresponding bases should be reversed. So all this just thinking about the output of this. Dissect the problem, break it into subproblems, and work backwards from the endpoint. So just in talking about the end product, we already realized two things. Just in the definition of a reverse complement, we know that there are kind of two problems to solve here, right? One is the complementary bases, right? We have a sequence, and we know that for every A there needs to be a T, for every G there needs to be a C, and so forth. But we also know that this is the reverse complement, so we need to somehow flip the order. So already we've broken this problem into two sub-problems. And we might know how to solve one, but maybe not the other. But at least we have a place to start, perhaps, in that case. Play around. Use a live programming environment. Try out snippets of code to test variable operation, functions, ideas. So, you know, imagine we have a string. You know, what could be our input? What could be our output? You know, we know there are rules for manipulating strings. This could be a place to start for you know, maybe reversing the sequence. We know that there is a rule, a string rule, an indexing rule that allows us to reverse sequences. Maybe you don't remember it, and we might have to go look it up later, but maybe just playing around with it could get us there. You know, we can start playing with for loops. If we're going to be doing operations on a string, you know, chances are we're going to be needing some kind of loop and performing operations on each base or each character. So we might try just, you know, making a simple for loop and trying to print out the bases in that sequence. Just playing around. You know, some of these things might be a hit or a miss. Draw a diagram. So you know, again, this is as I've said, it's useful to start from the end and work backwards. Another tip is to use black boxes or question marks on blocks of operations that you don't really know yet. You know, you start somewhere and start to draw a diagram. You know, like with a piece of paper, I recommend, you know, a physical, try to draw out a physical picture of what you think needs to happen. And you know, sometimes it might look like this. You know, we know we need to print something out at the end, so that's going to be one of the last steps. We know at the beginning there's going to be some kind of input sequence. That's easy. And you know, maybe we have a feeling that there's some kind of loop, right? And going on in this loop, we're somehow getting the complement. But we can put question marks there. Maybe initially we don't quite get it, but it helps just to get this far, right? Already we've kind of added a bit of structure to our program, and we've you know, broken it down into some of the more basic components that we're going to need later. Here's what a more complete loop would look like. So if we figure out the problem, we'll see that you know, inside this loop that's going through each character, each base, you know, we're going to need to do a series of tests, of decisions, conditional statements to check, you know, which of these bases is what. So if it's an A, then we're going to need some operation that you know, converts some variable into a T, because we know that if there's an A, then we need the complement, so we need the T, and we need to do this for each of the bases. And then we could have an operation at the end that just takes whatever base we decide on. If the input happened to be a T, then the output of this loop, of this portion, is going to be an A. Then we just tack that on to some growing sequence. This turns out to be the solution to the problem. You might not get that far, but oftentimes a diagram will get you pretty close. And then finally, research. So you know, Google. This is actually, you know, should not be underestimated. It's actually really important to do this. So let's talk about that. You know, we can just type in Google, you know, how to reverse a string in Python, and the first thing that comes up gives us the answer. Here we can see it as this double brackets, 2 colons and a -1. This is how you do it. How about how to loop through a string in Python? And we get you know, we get some suggestions here. And this is really an art. So you know, you have to get used to exploring the results. I think it's usually useful to check Stack Overflow is a good resource. So people will post questions, and you know, 99 times out of 100, someone has already asked the question you're trying to get an answer to. So it's not so much a matter of asking it again as finding the question. And Google happens to be really good at that. but it is an art. So, and it depends on your ability to describe the problems you're facing. And so I would say that this is something that really depends on your vocabulary. So being able to talk about programs in a precise way, this will really help you to Google your way through places when you get stuck. So knowing, for instance, that these are called modules, packages, or libraries. Knowing that this is called the iterator, the iterable, or the iterate. Knowing that finding the position in an array or a matrix, that this is usually called an index or indexing. Knowing, for example, in a function, if we have a keyword here, keyword argument, this is something we include at the end of the function that is optional, and allows us to specify additional information, supply an additional input. These are called arguments, whereas the main input is usually called a parameter. Yeah, knowing that these are called functions, right? If we have, np.zeros, zeros is a type of function. And we'll go through functions a bit more. So don't worry if that seems unfamiliar to you. But these are some more examples. So return an index from the max value of an array, Python. This returns a really specific post, actually, that is the exact answer that we want for this particular query. And it's not so hard, like, when we read it, you guys know all of these words, but notice how precise it is. We've really put into a sentence what we want to do. And this is so important. You don't just Google, like, lists Python, something like that, arrays Python. You're going to get the basic documentation back from Google, and reading the documentation it can be good to do, but it's long and dense, and it's not going to take you right to your answer. So you need to be really precise when you do this. For example, here, how to remove a row from a matrix, Python, and then the first hit that Google produces it, numpy.delete, a function from the NumPy library. This solves the problem. And you can see the problem here. It's just a matter of putting it into words. Some more examples. Read a CSV file into NumPy array, Python. So yeah, and here we get a Stack Overflow post. The top comment, I believe I recall from this post, very simply details the answer. It's a matter of copying and pasting it. How about this one? Invert an image, matplotlib, Python. Again, we go straight to the answer here. Sometimes you'll get something that's pretty close to what you want to do. So, maybe I want to make a plot for myself. So I might Google program that plots data, Python, and we get someone else's code here. And, I might just take this, copy it, and then change a few things, change the input to suit my own needs. And this can be a really great way to get started. Here's another example, how to plot a histogram in Python. Okay, so we have an example here, a full example. Someone had posted on Stack Overflow, and we just take the code directly, copy it, and modify it for our own purposes. Maybe we want to change the color, change the density of these bins, create more bins, create kind of finer, noisier data. And just remember, when you're doing this, if it's a long program, usually Stack Overflow posts, it's not an issue, but oftentimes it's appropriate to give credit or cite posts, or especially papers, when you take code from it. And the last step in the process is repeat. So if you didn't figure everything out in the first round, go back to the goal again. Maybe you're stuck again. Go back to the goal, read it again, try to figure out what it was you were supposed to make in the first place. Maybe after all your research, after all your tinkering, you've got some more insight at this point. Look again for subproblems. Try to break down even more. Break down the subproblems into sub-subproblems. Do this again and again until you hit the bottom, basically. Play around more. Just keep tinkering around in your live programming environment. Fix your diagram. If you had some question marks in there, some dark spots, try to fill that in. And refine your Google search. Maybe the first time around you knew, you had to do something with arrays, but now it's something to do with indexing and arrays. Try to add more precision and specificity to your Google search. So that's it. This is my process, and I think that a lot of problems, it's just a matter of not being too intimidated. Really just spend some time and work at it. If you find yourself saying the words, I have no idea where to start, just go through this list, try it, and try to pinpoint what it is you don't know, and examine that, reflect on it, and dissect it further. So that's it for this video, and I'll see you in the next one.